Hi, everyone, and thank you for joining us today. We will begin momentarily, just giving more people a chance to join us. So we will begin in about 1 minute. Okay, Andy, I think we can get started.
Great stuff.
So again, hi everyone, and thank you for joining us today. In the webinar today, we're going to talk about RAG, retrieval augmented generation. We will explore what is RAG, the pros and cons of using RAG and text-to-SQL, and some factors you should look at for ensuring your enterprise data is GenAI-ready. My name is Iris Zarecki, and I am Product Marketing Director here at K2View. And with me today is Andy Haler, Practice Leader at Lore Research. Great to have you with us today, Andy.
Thank you very much, Iris.
Glad to have you with us. And in the webinar, we'll focus on RAG and talk about what is retrieval augmented generation and how does it work? What are some of the pros and cons of generating SQL with AI? And some of the considerations for ensuring your enterprise data is GenAI ready. And as usual, we'll end with a Q&A session. So for the Q&A session, please use the questions tab just below the screen to submit your questions. You can submit your questions starting now and throughout the session, and we'll try to address as many as we can at the end of the session. So with that, let's get started, Andy.
Okay, well, thanks very much indeed, Iris. And just in case people are curious as to my background, I've basically had three kinds of elements of career, really. One was on the end user side. I worked for 7 years with Exxon and 13 years with Shell, where I ended up running data management across the world. And I set up a software vendor called Kaleido. And then for the last 15 years now, I've been an industry analyst, and most recently with Lore Research. So let's talk about generative AI. Certainly when it sort of ChatGPT came out from OpenAI in November 2022, it landed with quite a resounding thud on the desktops and browsers of the world, and raised huge expectations. I think people were quite amazed at what it could do in terms of write you an essay about the Industrial Revolution, or it could come up with some names, creative names for your new kitten, or whatever. It could apparently do a whole bunch of different things, and people started to think about what they could apply this to in different industries, maybe automating existing processes, perhaps creating content for writers. Other AIs that came out around that sort of period also can generate, of course, images. We've probably all seen AI generated images from things like Midjourney and other products, and obviously that's caused some impact and a bit of nervousness in the graphic design industry of people who do this for a living. So there was tremendous expectations, and certainly a torrent of money started to appear from the venture capital industry. So one statistic I read was that sort of 1 in 5 AI investments in 2023 were supposedly for AI related companies. So how much how close they follow the spec, I'm not quite sure, but it's certainly a lot. And certainly the valuations of the leading AI companies are absolutely astronomical relative to revenues, or let alone earnings. So tremendous expectations, but now we're almost best part of 2 years now into the sort of reality of trying to deal with generative AI. A few little clouds have started to appear on the horizon. In particular, it's an issue of hallucination, and this is a term that's slightly controversial, but it's essentially it's quite commonly used. And what it means is that the generative AI, which is essentially a probabilistic model, statistical model, will try to complete an answer based on your prompt, and it will do its best to come up with something that's what it thinks is statistically the most likely, the most promising answer. Sometimes, if it doesn't know the answer, if it doesn't have that in its training data, it will, on occasion, just invent stuff. And this is unfortunate. So, just give you one example, I just read the other day. There's an AI researcher called Gary Marcus. It's very well known, and so there's quite a lot of material about him on the internet. So it's the kind of thing that an AI who's been trained on a large chunk of the internet would have a lot of base data about him. And he asked one of the AIs to write a biography of him, just of himself, just as a little test to see how accurate it was. And it was mostly quite good. It got like the right university which he went to and so on, though it didn't quite get the subject right. But the most entertaining little omission or error was that in the middle of the biography it said, and Mr. Marcus, who sadly died in 2017, was a well liked, and of course this fact that he actually died came as something as a surprise to Mr. Marcus, given he was clearly not dead and was writing the prompt as we spoke. So this is just an example of an hallucination, and I think the very first query I ever put into ChatGPT generated a hallucinating answer, and I began to wonder how common it was. And there've now been quite a few different studies from different academics and other places. And although the numbers you'll see vary, this one, which I think was Stanford University, found that around a quarter of AI answers, generative AI answers, include hallucinations, and as many as over 40% have some kind of factual error. It may not be a pure hallucination, but something is not quite right in its answer, and that's kind of a lot. So if you think about it, if you go into Excel and you put two numbers in, and then you have a formula, multiply cell A by cell B, you get an answer. And what you don't do is you don't have to get a pocket calculator out and double check whether the answer is correct. We've all become used to the notion that if you ask a computer a question and it gives you an answer, we're used to the fact that it's going to be the right answer. And this isn't true with generative AI. I mean, it might be the right answer or it might not. And that's kind of a problem in many cases. May not matter too much if you're asking it for names for your new kitten. If it comes up with some strange names, well, so be it. But if you've decided to automate some process in Homeland Security in America, and you're trying to get the AI to recognize potential terrorists, you kind of don't really want it then to be too creative about things. You really want it to get the pattern recognition correct. Apart from that, there's also a sort of somewhat understated issue at the moment of just the sheer cost of actually running AI queries, which are substantial compared to other sort of typical computer operations. So at the moment, you may not be seeing too much of that, because at the moment, a lot of the queries are essentially running mostly in the server farms of companies like OpenAI and Anthropic and so on. So essentially they're being sort of subsidized by the American venture capital industry. But if you actually sort of cost out these things, they're non-trivial. So vendors who have starting to use AI in their own sort of work, definitely have to sort of start to calculate the real cost of running these things, and think about what happens when the people decide not to keep subsidizing these things, but actually to charge what it's going to cost. So there's a sort of an issue there. There's also a fairly well-known problem in terms of bias in the training data. So the generative AI is only as good, the large language model is only as good as the data it's been trained on. So if you, for example, there's an example, case in HR, one company where they confidently gave it a whole pile of their own staff and so on, and it just so happened that in this particular role there was a lot of white male people, and so unsurprisingly the AI confidently kicked out anybody from the resume pile who didn't fit that profile, and obviously that wasn't what was intended, but that's what it did, and so you have to be quite sort of careful about the training data. So that's just sort of a few sort of examples really of issues. Now if we give a few sort of real life examples as people started to implement GenAI in practice. I'm not going to sort of read out all these one by one, but just to tell you one or two. The most expensive one was probably the one on the bottom left, which was a property company in America called Zillow, who decided that they would use AI to help them find undervalued properties when they would then buy them at a apparent bargain price. This didn't work out real well, and the write-off they had to take once they discovered it wasn't doing the job was $500 million, which is kind of an expensive decision. For example, others are just more amusing. So the one on the bottom right is a UK example where the courier company called DPD has put a chatbot in instead of a human being. And one of the customers got kind of frustrated with their lost delivery, realized that he was talking to an AI. So he actually got the AI, asked the AI to write a haiku, a Japanese little 17-syllable poem on how terrible a company DPD was, which it duly did. A very elegant haiku appeared. This went viral and was all over the national news and so on. So DPT had to frantically, take down the chatbot and put back the people, at least for now. So there are many examples of this. There's been actually several in the legal industry. So the one on the top left is one example, but there are others where lawyers have, being a bit lazy, have used GenAI to generate pleadings to judges, including case law. So we refer in their statements to various precedent cases, and in many cases these are hallucinated. So some of them are right, some of them are not, and in many cases, in a few cases that have made it to the national news, they didn't check this, and when the judges actually read them, they realised these cases are just made up, and of course that doesn't typically go down well with the judge. So there's a few examples. There are many more, but the point is we're trying to get at is that although generative AI is incredibly sort of powerful and promising, we do need to be quite sort of careful how we implement it. And we're going to come on shortly to talk about a specific example of how we, well, firstly how we can try to improve that through a technique called RAG, which I'll come back to, and also talk about in the particular case of how AI can generate SQL. So
just to ask a quick question, Andy. So you said the honeymoon period is over, but we still see people trying to get the most out of GenAI. They're not giving up, are they?
No, I don't think so. I think I think if I sort of try to sort of summarize, there's a sort of dawning realization that they can't necessarily be trusted to come up with answers on their own in context. So what the people I think have realized is that they can be quite productive at coming up with, for example, a first draft of a letter or something, but you really, really, really need a human being to kind of review that and make sure that there aren't any sort of errors or hallucinations in the response. And I think that sort of notion of sort of augmented kind of, tools is the sort of thing. You find the similar thing, which we'll talk about soon, with in the programming world, where you've got these various sort of co-pilot type products which can generate code for you, but it's kind of alongside you, rather than necessarily replacing sort of human programmers. So I think that's probably where we'll get to, at least in the next few years.
Got
Uh, so maybe you'd like to chat a little bit about retrieval augmented generation. So one of the issues that you have if you want to put in something like a chatbot into a company for your customer service, clearly the AI on its own won't have a clue about your particular product order or your delivery. And so it's just no good asking chat GPT to where's my delivery, because it won't know. So what you can do is to take some kind of company specific data set or database or data sets, and take a base model, whether that's GPT, or whether it's Llama or something else that's already sort of a functional generative AI model, but then supplement its training data with this particular data set. So you might choose to add the customer order history, for example. If you're kind of a chatbot, you might want to put in your documentation of your product. For example, if you were a consumer goods company and you were putting a help desk in, then you can train the AI on the specifics of the product documentation. So that's the sort of basic idea of RAG, or retrieval augmented generation. And the only just little wrinkle there is that the format which LLMs, large language models, like to see is a particular format of numbers, and is not necessarily a comma separated value file. So in particular it wants to see vectors, and so you either kind of have to do one or two things. You can either implement a new database that's a specialist vector database, something like Pinecone or Weaviate, or use another database which has a vector search capability. And indeed, some of the mainstream databases are now adding sort of vector search as one of their options, but you do have to do that. So just be aware that you do need to talk to LLM in sort of the language of vectors.
Right. And elaborating a little bit on what Andy just told us, and again thinking about a customer chatbot kind of scenario, we see that the customer prompt is really the customer asking a question, and then the retrieval model will augment that with the internal data. Now, the internal data can come from a number of sources. There are sources that are called unstructured data that you see at the bottom of the diagram here, and they require vector search, as Andy described. And these would include things like company internal documents, knowledge bases, internal websites, a lot of information in those places. But in addition to that, there is the top box here that we call structured data. And this is data that resides in enterprise systems like Salesforce, SAP, Oracle, Snowflake. And they are structured data, so they require a query rather than a search to get the data from these places. So you would need to issue an SQL, a structured query language, in order to find that data. And in most places, in most organizations, what we see is that companies are using the LLM to create that SQL for you when they understand what kind of data you want to query, what kind of data you want to get. And this is what's called text-to-SQL, or AI generated SQL. And this is what Andy is going to talk about in the next slide. But before we get there, when we get the data, either unstructured or structured data, we bring it back to the LLM, we augment the LLM with that data, we provide some context to the prompt, and then the response back to the user will be much better, much smarter, much more reliable, and also personalized, which is very important. So, Andy, let's talk about the pros and cons of generating SQLs with AI.
Okay, so let's talk about this. And my background was I started my life, my career rather, as a database administrator, initially on IMS and then on DB2 back in the 1980s. So I'm sort of reasonably familiar with databases, and obviously one of the things that generative AI promises is the ability to generate not just answers in English or indeed Spanish or French or another language, but to generate answers in programming languages, and it can most definitely create programs in languages like Java or Python or whatever, and SQL, structured query language, which is the language of the relational databases like Oracle and Snowflake and the others. This is just another language to a large language model, so it can generate SQL just as it can generate an answer in Spanish. Now, this sounds fantastic. So all we've got to do is to type a question in English, and it will come up with perfect SQL answer. Well, in fact, the actual process of trying to generate text to SQL is not new. So the first attempt to this was somewhere many decades ago in sort of universities. So we haven't got some kind of track record of understanding some of the limitations and issues here. In particular, what the LLM is going to need, the large language model is going to need, is it needs to understand the schema. Okay, because if you think about it, if you're going to say, tell me my most profitable customer, or tell me what the 10 biggest sales orders were in the last quarter, again, that doesn't make any sense on its own to the LLM, because it doesn't know what the sales order is or what your database is and so on. So you're going to have to tell it. So in the prompts before you issue a query in natural language, you're going to have to describe the schema. And so this actually works exceedingly well for sort of demonstration purposes. So you can, be in a little demo, and there's a particular data set called the spider data set, which was originally devised by Stanford University as a kind of a test bed for AIs and text-to-SQL. And this has a bunch of tables and columns populated with some sample data, and a lot of the AI's vendors actually use this as a kind of basic sort of testing module, and this works very well when, as in the spider dataset, you've got a relatively small number of tables with in particular a small number of columns in each table. In the spider dataset, it's just a few columns per table typically. In the real world, it's a little bit more complicated. So if you're trying to query something like SAP, the ERP system, which is used in a very large number of big companies, SAP has got 120,000 tables. The customer master table, which is just the kind of table you might want to query, has got 257 columns. So if you start to sort of multiply those numbers in your head, or do it in Excel, I wouldn't do it with an AI if I was you, then you will find that you're going to be typing for a long time. Okay, and in particular, you're going to exceed the token limit of the prompt. In many different AIs have got different token limits, but essentially you're going to potentially have a problem. So at the very least, you're going to have to try to describe only the sort of subset of schema that you're interested in. And what actually happens in practice is, I've just was funny enough reading about this just the other day, people were puzzled as to why things that seem to work quite well on the spider data set didn't work when they applied the same query to a similar in production system. And the thing seems to be that the more columns you have, the worse the AI performance gets. So I don't mean performance in terms of speed, I mean in terms of the accuracy of the query. If you're, and many tables in practice, like I say, the SAP customer master table KNA1, so you've got say 257 columns. That's not unusual in a production system. You may well have tables with 100, 200, 300 or so columns. And what this study was showing was once you get up to around that sort of 300 level, the accuracy level of the generated SQL becomes actually really, really bad. So we're going down to about, instead of where on a small schema, it was happily knocking out sort of 65% accurate SQL, on a schema with large numbers of columns, it was down to about 16%. So there's a significant degrading. So that's one issue you've got to be aware is, is how firstly the AI needs to be made aware of the particular bit of the schema at least that you want to query, but also real life schemas with lots and lots of columns seem to be harder for the AIs to deal with. Now, what you can do, though, rather than just saying, "Oh, it's all a bit of a problem," one of the things that has been shown is that rather than just tell it the schema in the prompt, if you actually give it a few examples of queries, you actually literally write some SQL yourself and bring back a few numbers, and feed that as a kind of bit of prompt engineering before you issue the query you want, the performance, the accuracy level of the generated SQL actually improves quite significantly. In some cases, several times better. So that's one useful tip. Somehow the way that the probabilistic analysis of the LLMs work is that if it's seen queries that are a bit like the ones that you want, it's got a much higher chance of generating something that may actually work for you. So that's a non-obvious to me. I wouldn't have guessed that was a natural thing to happen, but it seems to be in practice that does seem to be quite effective. And now you've got to bear in mind that even with these tips, so even once you've told it about the schema and once you've given it some examples and so on, you're still going to have some issues. So the AI is perfectly capable of hallucinating bits of SQL, just like it's capable of hallucinating precedent legal cases. And
Mm.
so if you generate code, then it may hallucinate libraries that don't exist, functions that don't exist. Similarly, may refer to tables that don't exist or columns that don't exist. And actually, in some ways, it's not so bad with SQL because you're going to very quickly get functional errors back from the database optimizer when you try to run a bit of SQL with a column name doesn't exist. You get an error message pretty swiftly, so you can at least kind of quite quickly correct that kind of thing. But nonetheless, it's may just be annoying. It's also unclear how efficient the generated SQL may be. We all know if you've worked on real life databases of any size, that there's an awful lot of work goes into tuning the SQL in practice to get decent levels of performance if you've got a large amount of data to deal with. So that sort of tuning process is something that you're still going to have to deal with a generated SQL, just as you would have to do if you're coding it yourself. And to be fair, I mean, it's not junior programmers may not be writing terribly efficient SQL either. So it's certainly better to have the code generated for you than not at all. But it's just something to sort of bear in mind. The final issue is that, like with all these things in the worlds of computers, this old thing about garbage in, garbage out. If you're training an LLM on low quality data, then the likelihood is you're going to get relatively low quality answers. So in the case of RAG, if you're giving it, for example, customer history data or product specification data or whatever it is from your company, the data quality of that matters, and you're going to get significantly better results if the if the data itself is of high quality. So those are just a few things to bear in mind when you're looking at generated SQL.
Interesting. Thank you, Andy. And taking this again to the real world, let's look at a couple of ways organizations are looking at their enterprise structured data today and trying to organize it so that it's ready for GenAI and RAG processes and ready for SQL queries on the fly. So we really see three approaches. The first one is around going directly to the source systems, to the operational systems, and getting the data from there. What we see in this case is that organizations are writing and building LLM agents that focus on a single question, on a single domain. So if you think about the customer chatbot example that we gave before, we write an LLM agent that can answer questions about invoices. And then the LLM functions within that agent will go directly to the source systems that you see here on the left-hand side and get the data that they need from there. But the result is that unfortunately, this sometimes very quickly becomes a big spaghetti. So there's so many agents, LLM agents and LLM functions going directly to the source systems. And this becomes a little bit of a nightmare because you need to maintain a large infinite number of LLM agents and functions. For example, every time there's a change in the database schema, you need to change the LLM agent and the LLM function. This is quickly becoming not a realistic approach, going directly to the operational systems. Another problem that we see with this scenario is that there is a big risk of putting overload on the operational systems. Think about your Salesforce or your SAP system that Andy mentioned before. Typically, it was used by people from within the organization, so a limited number of people. And now we want to open it up to anyone on the face of the earth to ask questions about data in Salesforce. So there's a load problem and also a potential security problem. How can we limit and put controls in place so that people that get access through the LLM, through GenAI, also have the relevant controls in place to access only the data they need and not to harm or jeopardize the operating systems. So that's one approach, which is clearly not working today. Another approach that we see many organizations taking is using your data lake or data warehouse. So in this approach, instead of going directly to the operational systems, you put all the data in a data lake, and the spaghetti code issue is definitely resolved. It looks much better. The data is maintained in one place, and your LLM agents and functions can go directly to there. You still have a problem of maintaining thousands. We're working with a customer that actually has thousands of LLM agents and LLM functions, each one addressing a single domain or a single customer question. And it still is a little bit of a nightmare trying to maintain that mess of agents. But I think the bigger problem in this scenario is the security issue, because now what we've done is we put all the data in one place, and that's great because now the LLMs can access it there. But at the same time, now there's an issue of who can access everyone's data. All my customer data is in one place, and suddenly an LLM can access all customers' data when really what he needs is data about one customer only. So there's a big security concern here, and we heard about some recent security breaches, and there's definitely a concern, and it comes up in every survey that I read, Andy, that people are very concerned about security and privacy with
Yeah,
LLMs.
I mean, just to elaborate on that, because obviously in the underlying database, you can do all kinds of sort of restrictions, control based on user ID, or some people would put people within certain groups like admin people or users or whatever, and that all works perfectly, and the database will absolutely respect that. But if you're generating your SQL through an AI, you can probably give the AI engine sysadmin type access because it kind of needs to get to a lot of places. And are you able to tie back the level of access that the generated SQL will have back to the level of access that the particular user ought to be having. I mean, that's something that probably doesn't happen automatically. Probably requires a certain amount of planning and forethought. So yeah.
Right, exactly. Which actually leads me to the third approach that we see is the organizations using a data product platform approach to kind of reorganize the data for GenAI and make it ready for GenAI in a new way, a new paradigm, I can say. And what this means is that we collect the data and organize it by business entity. For example, this could be a customer entity, which is a perfect match for a customer chatbot. The data is organized by business entity, as you can see here, and now you need to map it back to the organizational systems or operational systems to make sure you're getting the latest and greatest data from there. And the GenAI agent can now dynamically query everything they want to query about one business entity, about one customer. Now, this approach is better because the business entity that you see here in the middle is a living and breathing creature. It continuously syncs with all the data sources, so the data is fresh and up to date. The data is also cleansed because if there's some conflicts between the data sources, you can fix them and clean the data in the platform, in the data platform. But maybe the biggest thing is that the data is isolated and it's protected. And when the LLM agent is trying to access the data via an SQL, it only has the access to one entity, to one customer. It cannot go beyond that one customer. And that's a big deal when it comes to assuring security and privacy with GenAI projects. And the result is that once the data is organized in this new way around the business entity, around the customer data, a customer entity, it's ready for GenAI and RAG, and it's also prepared for any questions. So you don't need to write thousands of agents, each one addressing a question about invoices and another one addressing questions about products the customer has, et cetera, et cetera. You can address all the questions with one agent that goes straight to the business entity, to the customer entity, and has all the data that he needs to address that question. So security and privacy is so much better here. The data that you need to query, the SQL that you need to generate is so much smaller, which is great because you're not going to waste token and all of that and context with the LLM itself. You can do a very simple query, get the data you need, and only the data you need, and get the answer you want. And also, it's interactive and can provide conversational latency to the customers. So again, think about a customer chatbot scenario. There could be thousands or tens of thousands of customers chatting right now. Can your data infrastructure support that kind of scalability issues? We see that scalability is a big deal, a big obstacle for organizations today trying to move GenAI projects from pilot to production. And with this approach of a data platform, it's really able to sustain that kind of load. So to summarize, I want to encourage you when you're looking at options of accessing your enterprise structured data using SQL, using text-to-SQL mechanisms like Andy described, make sure to look at each one of these six elements, six factors that you see here, and to make sure that you have the right answer, which is good enough for the application or the use case at hand. So for example, we talked a lot about security, but you must make sure that the data is isolated, the data is masked, it's encrypted, and it supports all kinds of privacy regulations like GDPR compliant. We talked about interactive and fresh data that must provide right now answers with right now data. We talked about scalability, but I think most importantly, and coming back to Andy's point at the very beginning, it's about reliability. When the LLM is augmented with trusted data, it can provide trusted answers that are also personalized and reflect exactly the situation with this specific customer. So please make sure to consider all of these factors when choosing the right data approach for your GenAI application. So with that, let's move to the Q&A session. Okay, so for the Q&A session, and we're right on time, so that's great. I want to remind everyone to use the questions tab just below the screen to submit your questions. And I see already some questions coming in, so that's great. We'll take them in a moment. I also want to remind you that you will get a recording of this session in the next couple of days, and that you also have some attachments in this session that you can download right now, including today's slides, the paper that Andy wrote about RAG to riches and text-to-SQL, and a couple of blogs that describe the pros and cons of the different data infrastructure approach that I discussed. So feel free to download any or all of those attachments for your benefit, for your use. And maybe one more thing is that if you'd like to see a demo of the K2View solution for enterprise data RAG, we'll be happy to provide a demo. And you can go to the poll tab below the screen and just let us know that you want a demo of our approach to data product approach to enterprise data RAG, and we'll be happy to share that with you. So with that, let's get to the questions. Andy, are you ready?
Far away.
Okay, so I think that this is a good question for you. So let's start with that. How does data quality play in the world of AI?
Okay, so I think there's maybe two aspects to that. I think we mentioned earlier that if you're going to do RAG, then you're going to augment your LLM with additional external data. Then the quality of that data is quite important, because the LLM's answers are only going to be as good as the data it's trained on. So if you train it on low quality data, then you're going to get low quality answers and so on. There is another aspect to that, which is that AI, but not generative AI, has been used in data quality for some time, which is around the area of merge matching. So if you think about you're trying to put together a data warehouse or master data management system, you're trying to perhaps combine customer records from 5 or 6 or 10 different systems, which have all got a customer record that has like Andy Haler or Andrew Haler or Andy D Haler or whatever, who all happen to be at the same address and have the same sort of social security number. In cases like that, then there are a whole pile of sort of merge matching kind of algorithms that can help you. And but obviously sometimes you'll get borderline cases which are more difficult and are not quite so obvious. And one of the things that's been used for some time is notion of machine learning, where a human sort of domain expert will sift through these kind of gray area sort of borderline cases, and the machine learning algorithm will follow the human doing that, maybe for hundreds and hundreds of examples, and itself will then get better at copying the behavior of the human. So I think that's another context in which AI can be used in the world of data quality, though in this case it's machine learning and not generative AI.
I agree, but we definitely see a rise in the concern or the focus on data quality because of GenAI.
Yeah,
People
and I mean,
understand, garbage in, garbage out, exactly.
yeah, yeah. And if you actually, I mean, I've been working in this area a long time, and I mean, if you do surveys of how reliable corporate data is, and you go back over the years and you look at surveys that I remember running, some in 2006, 2007 at my previous company, if you take the latest ones around the 2023, 2022 area, then surveys by companies like KPMG and Deloitte of large numbers of executives generally reckon that only about 1 in 3 executives trust their own data. And that number has been pretty consistent now for at least a decade or two. So despite all of these sort of investments that people have made in ERP systems to try and reduce the number of systems, in data quality software to try to improve things, nonetheless there's still a lot of issues with that. And if you look at something like a material master file, on average there will be around 20% duplicates to this very day. Data quality is a very thorny problem that's very, very hard to eradicate, but it does have this particular consequence in the world of generative AI, where you're relying on that data to train your LLM
and to provide answers to the end customer as well. Right. Great. Here's another interesting question from Randy. Going to my lake house for a chatbot, for example, the data lagging behind lake houses and production would be a concern. So I completely agree with you, Randy. That's exactly the thing you need to consider. If the use case is a chatbot which requires latest and greatest information, again, think about a customer. You don't want the chatbot to tell him he didn't pay his bill when he actually just did a minute ago. So in these use cases, when the data needs to be 100% fresh and up to date, data lake is not a good solution exactly for that point.
Yeah, and I think obviously, it, as you say, it all depends on the use case. I mean, for other examples, it may be perfectly reasonable for the data to be yesterday's data, but for any kind of operational thing like that, where you're looking at live orders or something, or if you're a financial system looking at live trades, I mean, you clearly, you're not interested in something that's from yesterday. So you just got to be, I think, just aware of the use case there.
Right. Absolutely. Here's another great question. What about scenarios that involve both structured and unstructured data? Andy, you want to take it first, or should I?
Why don't you start, and I'll maybe add something.
Okay, great. So I think it's a great question because all the use cases that we see at K2View, and we work with many customers on use cases like chatbot and customer-centric and others, they always require structured and unstructured data together, and one is not enough. And even in a survey that we ran recently with 300 enterprises, we got the same results. Maybe half and half. Half of them are using structured, the other half are using unstructured, and all of them are using both. So it's definitely a complex thing to do, to integrate, but something which the real world definitely indicates or requires. Now, the K2View solution definitely uses our no-code visual data agent builder to help you do this integration between unstructured and structured data. So we can run an SQL query to get the relevant structured data and a search in a vector database to get the other data and combine it together in our solution.
Yeah, and I think you just said the magic words there of the vector search, which it may be required to to access certain types of data that to make it readable to the LLM, where obviously structured data is it doesn't it works through SQL, that's different. So yeah, you may well have to combine different approaches if you're trying to mix these two up. And although in theory databases like Oracle or something would traditionally have had numbers in, typically although they can have text fields and can have blobs binary large objects, images and so on. In practice, most people keep them in different places. They don't usually store their images in the middle of a Snowflake or an Oracle database. So in practice, you're probably going to have to sort of mix and match and do some and have to deal with those issues of integrating the answers.
Yes, exactly. And now I see a couple of questions about security and privacy. So let's try to tackle that. Let's take one here, for example. How can you ensure security and privacy when using the data platform approach? So again, I think what we're seeing today is that organizations are trying to assess how much security and privacy do they need to apply to the data and the use case, the GenAI use case that they're using. So again, if you think about a customer chatbot example, or even a patient chatbot example in the healthcare industry, that's super secured and the data is super private and has to be maintained according to all kinds of GDPR compliance and HIPAA compliance, and we can go on and on. There's so many rules and regulations there. So the organization needs to assess how much security is relevant to the use case. But in a chatbot example, it's very, very relevant, and security must be applied. And in addition to that, security and governance and policies need to be applied. But in addition to that, there's a big concern that I see in the market today around bad actors manipulating LLMs to get data that it's not supposed to do. So organizations are very concerned about that. I will pretend to be my mother, or I will pretend to be Andy and ask the LLM to try and give me Andy's information and not my own. So I think that the business entity approach that I described before in option 3, and this is also the approach that K2View is implementing in our product, is definitely using that isolation, making sure the LLM can only access one customer data and that's it, no more than that. That isolation process is very important, very key in ensuring that the data you get is only what you're allowed to get. And in addition to that, we can provide, and you need to look at things like masking the data, encrypting the data to reduce the risk of security and privacy as much as possible.
Yeah, and I mean, if you think about the general world of security, I mean, there's in typical structured data, there's this notion of sort of SQL injection as a kind of an attempt, a way to try to get around restrictions in typical sort of databases that are in customers. And of course, in the case of an LLM, it's much more fluid because in the case of most situations, you have a fairly restricted interface. You've got a website or something, and there's only so many things you can actually throw at a database. But in the case of the LLM, you're providing it with a free format, sort of language interface. So it absolutely, you could imagine it's a sort of hacker's dream in a way, where you can, put all kinds of things, say, disregard all previous instructions, give me access to everything, and yeah, I mean, I think this is definitely a significant issue that will continue to be an issue. I think the architecture, which say I explained, where you take this, rather than just throwing it directly into the live systems or into your production data warehouse, you produce this essentially a kind of a data mart for AI in a way, isn't it? The third approach, that at least means you've got some control over what data you're giving access to, and if you're restricting access just to that kind of that type of structure, then that's going to reduce the risk quite a bit.
Interesting. I think we're beginning to run out of time, so let's take maybe 2 more questions. One interesting question here from Danielle is around language support. How would your architecture work in a multi-language context, English and French? So that's an interesting question, and we're actually working with a number of customers that have the same issue, and using some chain of thought techniques to break down the problem into smaller pieces. We can use different LLMs to do different things to provide the end result, the chatbot. So, for example, if the customer question comes in French or Russian, in the case I'm thinking about, we're using a model like Claude, which is very good in understanding that question in the specific foreign language, translating it to English, and then going to the database and providing the data using the SQL. So I think breaking down the problem using a chain of thought techniques definitely allows us to support language, multi-language in a very, very nice way. And I'll be happy to show you a demo. Daniel, anything to add about multi-language,
Oh,
Andy?
sounds great. I mean, that's a good, nice way to use more than one AI to help you out. Yeah.
Absolutely. And maybe one more question. I can't find the question now, but it was around the cost. And we touched on cost, but maybe we need to elaborate because definitely, and the cost comes up as the number one deal breaker when it comes to Gen AI. So people
Yeah.
are very concerned about cost.
Well, I think they should be, because, as I say, at the moment, the a lot of the true costs are actually being disguised. And if you look at OpenAI, which is like the biggest vendor, or the leading vendor, I guess, of an LLM. I mean, they are doing what, 3 billion revenue, 3.7 billion revenue, but they're losing $5 billion on that revenue. Now, okay, the thing's still valued at a couple of hundred billion or whatever, but essentially they're losing money to hand over fist at the moment, and it's probably the same case for other AI sort of startups, at least. And a lot of that is because they are subsidizing the cost, or the investors are subsidizing the cost of running the queries, which are not non-trivial. Now, say one day this will not happen anymore. I mean, there's a bit like Uber with taxis. Initially, Uber came in, very low price, bankrupted all of the minicab companies around, my local area, and everyone just stopped running taxi services apart from Uber. Now Uber's price is back up, a bit higher now, and for years and years Uber was losing money, but then at some point they decided they'd done what they needed to do, and they've got their market share, and they jacked up the prices, and this is surely going to happen in the world of AI, where there's only so much money that even a VC is happy to lose, and at some point a more realistic pricing structure will happen. It may not be this year, maybe not be even next year, but you do have to bear in mind that at the moment the AI query processing costs are essentially a fraction of the real and true costs, and at some point you are going to get a bill for this in the future.
Right. And what I'm hearing from customers is that they want to be able to predict the cost,
Yeah.
because right now it's going out the roof and they feel like they're losing control. And this is not only the token price, it also has to do with the query prices.
Mhm.
Querying your Snowflake is not a cheap thing, and you want to know how many queries you'll have to do in order to answer a customer question.
Absolutely, and then you're getting back into the whole issue of kind of cloud databases, and one of the most common complaints that people have about very otherwise very powerful databases like Snowflake is they get sort of unpredictable bills. On AWS, any kind of processing that goes on there, you're not entirely sure what the bill you're going to get at the end of the month is. This is if you're chucking AI into the mix, and it's the one generating the SQL, then you're one level further removed from being able to understand what's going on, and therefore the level of unpredictability will increase. So yeah, no, it's a definite issue. I mean, that will maybe drive some people back into private cloud configurations, because at least you lose some of the benefits, but at least you're in some control of what's going on because you own the processor and so on. But yes, it's going to be a sort of tension, I think, between the public cloud and private cloud sort of approaches, and this is going to definitely exacerbate that debate, I think.
Yes, absolutely. And I do see a couple more questions, mostly around demos. So I promise to get back to everybody around the demo and show you exactly how the K2 View solution works and how we can create and maintain a business entity or a customer entity and keep it fresh and up to date and available for the LLM to ask any question and get an answer. So we'll be happy to show you that and the K2 View solution in a private demo. So we'll get in touch with you. But with that, I want to thank you, Andy, for spending the last hour with me. It was very interesting.
Thank you for asking me on.
And I want to thank everybody in the audience for joining us today, and I hope to see you in our next webinar. Thank you. Bye-bye.